Hello everybody, I'm Anantha Padmanabha. I'm an assistant professor in the Department of Computer Science and Engineering at IIT Madras. My research work broadly involves working on the foundations of computer science. Let me give you a couple of examples to illustrate the kind of work that I do. In the field of databases, I'm currently working on the problem of consistent query answering. This involves answering queries in inconsistent databases. As an example, suppose we are building a database of people living in a city, and we want to build this database using information collected from cities' various administrative services like gas, electricity, etc. And we want to store every person's first name, last name and address. Now, when we are doing this, there could arise a situation where for some person, address in one record might be different from the address in a different record. Why would this happen? Maybe because the person moved to a different place and this has been updated in one of these records, but it has not been updated in the other record. In such scenarios, we have to choose between the two addresses. Now, if we do not know which of these two is the latest information, then we don't know what the right choice is to put in our database. Consistent query answering deals with such scenarios where we try to come up with a strategy to answer questions in these settings. Intuitively, suppose let's say the person has moved from 1st Cross Gandhinagar to 3rd Cross Gandhinagar, then we want an algorithm that takes a query as input and does the following. If the query asks, does this person lives in Gandhinagar, then we want the algorithm to say yes, or we want the algorithm to output yes. But if the query is, does this person lives in 1st Cross, then we want the algorithm to say I don't know or I'm not sure. We have designed algorithm for this purpose, and we have also worked on understanding for which type of queries this task is easy, which means that it takes less time, and for which task it is hard, this task is hard, which means that for such queries it takes a lot of time. Another problem that I have worked in the field of databases involves graph databases. Those who are familiar with databases would typically think of relational databases when we talk, or SQL databases when we talk about databases, where the data is stored as a table. But data can also be stored as a graph. For instance, if we are looking at a movie database, we can also store this data where every movie is stored as a vertex in our graph, and every actor is also stored as a vertex in our graph, and we can have a labeled edge called acted in from some person to a particular movie if that person has acted in that movie. Graph databases have many applications like knowledge representation, semantic web, etc. One application of graph database is something that you might have experienced. Since a few years, if you ask Google questions like what is the capital of India, it will directly answer New Delhi. But earlier, like last 5 to 8 years ago, if you had asked the same query, it would not give you the answer, but it would only give you a list of links where you could find this answer. Now, how does it know this answer directly? Well, it has a graph database of its own, inbuilt graph database, where India is a node and New Delhi is also a node, and there is an edge called capital of from New Delhi to India. And all it has to do is go to the node India and search from which node there is an incoming edge called capital of, and it will directly output that node, in which case in this case the answer would be New Delhi, right? And the point here is that the search engines can use this graph representations to actually find the answer. Now, even now, if you ask a complicated question to Google, it will still not give you the answer, but it will give you a lot of links where you can potentially find the answer. Now, if you want the Google to directly get this answer, we want better algorithms. We have to develop better algorithms to process queries on graph databases. We are working on designing algorithms to process queries on graph databases. And currently, one of the problem that we are looking at is to see when can we reduce evaluating a query on graph database to evaluating a query on relational databases. Now, why is this useful? Well, because SQL has been there for a long time, and there have been a lot of optimization techniques, tools that have built for SQL databases. If some processing of a graph query can be reduced to processing a query on SQL database, we can use all these tools that have been built for SQL databases to answer this graph database query, wherein we can do it very quickly. Now, this is possible for some queries and this is not possible for some queries, and our work basically tries to understand for which queries this can be done and for which queries this cannot be done. And we ideally want an algorithm that takes a query and says, yes, for this query we can use techniques from relational algebra or SQL database, and for some queries this cannot be done. These are some of the examples of the kind of problems that I'm working in database foundations. I'm also interested in other topics like modal logics, finite model theory, game theory, etc. The underlying topic that unites all these seemingly different topics is the application of formal logic in computer science. If you want to know more about these, please contact me and I would be happy to discuss it with you. Thank you.